Hello, we are Team 19103 and we were tasked with designing and developing a ferret enrichment chamber apparatus. The ferret enrichment chamber apparatus was designed for the collection of natural ferret behavior for the multi-scale brain imaging lab that is headed by our sponsor, Elizabeth Hutchinson. This lab focuses on better understanding brain disorders through preclinical imaging, and in specific, this lab is focused on developing traumatic brain injury models through MRI imaging. The ferret enrichment chamber apparatus was designed to be utilized in this TBI study. However, our project has nothing to do with the study itself, and our focus was just to design and develop these chambers. The system employs RFID readers to automatically collect each ferret's unique 32-bit RFID chip, location, and timestamp upon entering or exiting any of these three chambers. The chambers are fabricated out of acrylic for durability and for the ability to see through them. Each chamber is 3 feet wide by 4 feet deep and 3 feet tall. Here in the middle is a top assembly drawing of one of our chambers just to visualize what the design looks like. The system works through an RFID reader that is integrated above each one-way passageway in order to collect the timestamp, location, and RFID chip of that ferret as it passes through a door. From here, the user has the ability to export the data to a CSV file through the GUI that is also shown in the middle column of our poster. This GUI also enables the user to implement various functions such as checking where a specific ferret is at that current time, turn the system on and off, and add any additional notes to any of the ferret's information. Next, Haley will be discussing some of our system requirements.
This is our system requirement verification table. We were able to pass all of our system requirements, and I'll be going over a few of our key requirements for the system. For the performance, we have a requirement for the accuracy, stating the system shall be able to record accurate data of the time spent for each ferret in a chamber with an accuracy of plus or minus 1 minute. This was verified by a test where we would have the phantom ferret scanned by the RFID reader as it enters the chamber, and then wait a minute and scan the phantom ferret with an RFID reader once again to show that it has exited the chamber. We timed this with the stopwatch and compared it to the time our system captured, which was 0.47 seconds off from the stopwatch time. Therefore, this requirement passed. For our interface, we have a requirement for the GUI. This is verified through demonstration. We will be going over this in more detail in later slides. The next requirement we will look at is the requirement for the file type. The system shall be able to create a file that distinguishes each ferret, the time spent in each chamber, and create a section where the user can insert notes to log information. This is verified through a demonstration and a test. We will be going over this in detail and show you our output file in a later slide. The last system requirement I'll go over is one for the design features regarding the passageways. The system shall use one-way passageways to get in and out of each chamber and only allow one ferret to go through at a time. This was verified through a demonstration and an inspection. In a few slides, you'll be able to see a video that shows how our design was implemented into our chambers. Here's Alex to go over the GUI.
The system can be started by double-clicking the Fika icon on the desktop. The GUI that appears shows a status box and a ferret info box. The status box allows the user to start and stop the system as well as export data to the desktop. The ferret info box allows the user to view the tags, current locations, and notes for each of the ferrets in the system. New notes can be added for a ferret with the Add Notes button by entering the ferret number and the desired note. It automatically appears in the notes section for that ferret. Likewise, notes can be removed using the Remove Note button by entering the ferret number and fragment of the comment to be deleted. If a matching comment is found, the entire comment is deleted. If the fragment appears in multiple comments, none will be deleted. Ferrets can be removed from the list with the Remove Ferret button. However, their timestamps will remain in the database. The timestamp CSV and comment log files can be exported to the desktop with the Export Data Files button. This creates a timestamped file in the output folder on the desktop. The timestamped file contains the comment log text file showing comment additions and removals, as well as the timestamp CSV showing ferret location information. When a ferret tag is read by an RFID reader and sent to the Raspberry Pi, a new row is created in the output CSV file. Each row consists of the read tag, the chamber the ferret was in, the entry and exit times for that chamber, and the total duration in seconds spent in that chamber. Next, Jared will go over some of the demonstrations.
Here is the front wall design showing the one-way door passageways. The RFID reader is located above the entrance with the wires connecting to the RFID transceiver on the opposite side of the wall. No wire coverings are added to this image to show that the wires are going through the wall to the transceiver. The wire coverings will be included in the deliverables. The testing of the chambers is taking place in a different location than where they will be assembled, so the walls currently have a paper covering on them to prevent scratches on the acrylic. Once they are in the animal facility, the coverings will be removed and the walls will be see-through. This video shows a puppet ferret exiting the chamber through a one-way door. As you can see, the door shuts behind the ferret, making it unable to enter through the chamber exit. We wanted to include the ramp design in this video, however the ramps were misplaced by the supplier, and we won't be receiving them until April 20th. Now I'm going to hand it over to Carrie to go over a ferret passing under the RFID reader.
This video shows a puppet ferret with an embedded RFID reader passing underneath one of our one-way doors. This ferret's RFID chip is able to be read by the RFID reader, which is above the door, and our program is able to put a timestamp and a location into our database in GUI once it passes underneath. We have had to use a ferret puppet for testing since we are not authorized to use real ferrets at this moment, since real ferrets are able to contract and transmit COVID-19. This puppet ferret, though, is representative of the actual size of a larger ferret, and the RFID chip that is placed inside this puppet is in the actual location of where it would be in a real ferret, so that our testing would be as accurate as possible. So this is the animal facility. It is only big enough for us to place one chamber in it at the moment until we get a larger room. And we were able to actually fully assemble this chamber in the room with an enrichment activity as well, so that when the ferrets arrive, they will have one chamber to get accustomed to. This chamber was assembled by Elizabeth Hutchinson and one of her team members, since we are not allowed in the room itself. This is a closer up version of what the chamber looks like with the ramp design and the wire coverings on it. And this is the inside view of the chamber to show that the animals will be able to exit out this ramp and enter in through the one that's on the outside of the chamber. Lastly, Team 19103 would like to take a moment to thank some key people in helping us complete our design and making it come to life. We would like to acknowledge specifically Elizabeth Hutchinson and the Bioscience Research Labs for allowing us to use their lab space for assembly and testing. We would also like to acknowledge Dennis Woods at Total Plastics for helping fabricate our chambers and other parts, as well as helping us overcome certain obstacles to our design. We'd also like to thank the judge panel for their feedback on all of our presentations, and Gary Redford for his mentorship and help throughout this whole process. Thank you.